All right, so I'm going to go over problem 11 here in the book. This is on page 468. I actually think this is very complicated and very easy to get wrong, okay? So we're going to walk through and figure out what's happening. All right, so, and I know my drawing's over this, so I apologize. Let's get rid of this. So let's look at A, and let's look at all of these. And we can see that these are all secondary alcohols because we have an alcohol attached to a carbon that is attached to two other carbons. All right, so we need to recap what we know about alcohols. So the way I look at this is primary, secondary, tertiary. And when you're working with alcohols, you need to be 21 to drink. So right now, we're just working with substitutions. You need to be 21 to drink, so you're going to match your 2's and your 1's, 2 and 1. So what do I mean by that? This makes 21, and this makes 21. And we all know that 31 is the new 21, so this is going to be SN1 also, okay? These are going to go under carbocation rearrangement, okay? They also are going to form two products. If we have a stereocenter, two enantiomers, and our inverted is going to be preferred. Okay. Well, what about an SN2? Well, there is no carbocation here. And it's one product, and it's inverted, okay? Also with SN2 is going to be anytime we see a pyridine, okay? So now that we know that, let's look at our first one here. So let's look at A. And we have this, and we have this, okay? So right now, our, quote, leaving group is this, but the whole idea behind this chapter is alcohol is a bad leaving group, so we need to get rid of that. And we have a two-step reaction here. We're adding a Br pyridine, and then we're adding a nucleophile, methoxy. Two steps. All right, so what's the Br pyridine gonna do? Well, first of all, this is a secondary alcohol, and this is gonna go under SN1. So we are subject here to carbocation rearrangement, okay? Go there. Oh, but, see, I almost fell for it. This is an exception because pyridine automatically converts this to SN2. We do not have to worry about carbocations here. So our OH disappears. Bromine takes its position. Now we have a good leaving group, right? What a great harmony this is, Br to O minus. However, because this is substitution, bromine is coming in from the opposite direction. Remember, we're going to get, for an SN2, one product inverted. I should have kept that in there. So this bromine is actually going to be on a full wedge. But now the nucleophile comes in, okay? Now we have a secondary alkyl halide. And now we really need to remember what goes under secondary for alkyl halides. SN2, SN1, E2, and E1. E2 has one letter, two letters that goes under primary and secondary, as well as SN2. So this is going to be tertiary, secondary, primary. And this one, and this one. Great, I'm going to be on Instagram without a mask on. Sorry, this is just the way I do this. Okay, SN2 does not go under tertiary. SN1 and E1 compete. E2 can with a strong base. This goes in a 1, 2, 3 order. This goes in a 3, 2, 1 order. Okay. So anyway, we have a secondary alkyl halide. Secondary alkyl halide either goes under SN2 or E2. In this case, SN2 is favored. So we're going to continue with substitution here. Okay, so our nucleophile comes in, which is methoxy, but it's still going to come in from the opposite plane, which is why our answer is this. Put the CH3 here if we want to. So that's why that's the answer, which it is. That's for A, double checking here, and that's correct. So yeah, there's a lot to think about. There's a lot to think about with these. So let's move on to B. This is really putting a lot of concepts together. So now we have a methyl here and our poor leaving group here. What are we adding? HBr, okay? We're just adding HBr. Okay, and this is a secondary alcohol, so this is going to go under SN1. We are subject to carbocation rearrangement here, okay? The actual mechanism of this is that this gets protonated, water comes in, bada bing, bada boom. Bromine's going to come in, but it's going to come in. Oh, wait, hang on. I'm sorry. There's a carbocation intermediate. So when this gets removed, after all that, there's a carbocation. We have a hydride shift. Our carbocation is going to sit there, because remember, this was secondary alcohol, SN1. Okay, it's still going to be inverted also. Now, Br can come in. And because OH was in this position, carbocation comes here. A bromine is in the way, so it kind of has to be like that. But this trips me up a little bit. I'm not actually sure which one is the major product here. And this would be, so these are our two products, this one and this one, okay? In terms of an inversion, if bromine is coming in from the back, I don't know, I would guess that this is the major product just because bromine is on an opposite plane as our original OH, okay? But that is what's going to happen there. Okay. Or maybe you would even do an R and an S. No, but the first one has two stereocenters. I don't know. We're not going to worry about that. Let's move on to C. And let's look at what's happening here. We have a methyl. We have an OH. Another two-step. We see a pyridine. Pyridine, SN2, Inverted, no carbocation, okay? So inverted, no carbocation, so we're not going to put a carbocation, we're not going to do any type of shift. Alcohol was unadashed. The Cl from this SOCl is going to be here, but now we're bringing in a nucleophile. Now we're bringing in methoxy, okay, on a secondary alkyl halide, which is going to be SN2. So it's going to come in inverted and look like that. So let's double check that one. That's C. Yep, that's the answer for that. All right, final boss here is D. Methyl and an OH. So it's the same starting product as the first one. But this time we're adding TSCl. So what is TSCl? Well, this is going to be it's like a sulfoxyl group that initially comes in. This is a sulfoxyl group that initially comes in. I believe it's still in an SN2. That's C. This one. See, this one's a little bit more confusing because I think for some reason the methoxy group is not altered here. TSL does not cause an inversion. So that's going to be an exception. TSCl, no inversion. That's a good trick. So when TSCl comes in and ends up putting it, it's not even a Cl, it's this whole sulfur group. It's this whole crazy thing. That is then going to become the leaving group. That is going to leave, and we're going to come in with our nucleophile, which is just methoxy. Methoxy, however, comes in from an opposite plane. So our final product is this. Wow. So there's a lot to think about here. But there it is.